Hello again. This is Math 2270 coming to you from the College of DuPage, and the title of this lecture is LSA 2 about Virga precipitation. As always, be attentive while watching this video. You may have observed rain in the upper atmosphere, which evaporates prior to reaching the ground. This problem deals a little bit with such a phenomenon. As you know, serious meteorology is very mathematics intensive and treatable mostly through simulation modeling of systems of differential equations, and in fact partial differential equations. Some notes are presented here, followed by an LSA2 for differential equations that I'm asking you to think about and solve and submit. Okay, so here we go. This is an article where I took this stuff from. And the title of the article is, What is Virga precipitation? This weather phenomenon occurs when rain or snow doesn't reach the ground. Picture is sometimes said to be worth 1,000 words, and so here is a picture of Virga. Virga is the name given to precipitation, usually rain, that evaporates or sublimes before it hits the ground. It tends to look like wispy gray streaks hanging underneath the base of a cloud. For this reason, you may have heard Virga referred to as fall streaks. The storms that are associated with Virga produce trace amounts of ground level precipitation only. So why the funny name? Well, keeping in the tradition of clouds whose names are Latin, it's derived from Latin word virga, which means twig or branch, and likely referring to the delicate streaks it produces. So these are like delicate streaks. Virga is produced when precipitation falls from high clouds into extremely dry air, low humidity, and high air temperatures below. Virga is commonly seen across the desert regions of the United States, western United States, an area prone to both low humidity and high temperatures. As the liquid raindrops or ice crystals hit the warm, dry air, they absorb the high energies of heat, the high levels rather of heat energy, which energizes the movement of the water molecules, transforming them straight into water vapor, sublimation or evaporation. Eventually, as more and more precipitation evaporates into the air becomes moister still, the relative humidity rises. If the precipitation is light, it can take several hours for the air to saturate with this humidity. As the air saturates first aloft and then down to the surface, a kind of moist pathway is carved out that precipitation can follow to the surface as rain or snow. Like all light precipitation, this shows up on radar as light shades of green or light blue if it's snow. However, with Virga, when the radar may detect it, your eyes won't. And if you've ever watched a radar screen and seen a leading edge of rain or snow band over your location, but not seen any rain or snow actually falling outside your door, it might have been Virga. This is common in the winter, especially waiting for the start of a snowstorm. We've all heard meteorologists say it's already snowing in the upper atmosphere, but the surface is too dry to see it. It's easy to mistake Virga for distant rain shaft. That's a dark curtain of rainfall extending from the base of thunderstorm down to the ground. The biggest giveaway for Virga is it won't reach the ground. It's also theorized, not proven, that Virga is partially responsible for creating punch hole clouds. In addition, Virga high in the atmosphere can reflect sunlight, creating brilliant sun pillars and other atmospheric optics associated with the sunlight. LSA2 then. A raindrop has a radius of 1 millimeter. If the raindrop takes 4 seconds to evaporate, determine the volume of the raindrop as a function of time. Assume that the raindrop is spherical. Now this is due Friday before midnight. I'm targeting 11:30 p.m. and I still need to do this, but that's when it's going to be due. This modeling problem is somewhat subtle physically, so I'm encouraging you to look and think about this before you leap. I also have to make, in addition to making the landing site for this. An answer sheet will be made available on Blackboard soon, and this presentation will be placed in your syllabus tab. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourselves and of each other. We're all in this together. May God bless you all.